If you took every star in the observable universe, every planet, every moon, every asteroid, every grain of cosmic dust, and compressed it all into a single region of space, it would occupy less than 1/billionth of 1/billionth of 1% of the volume it currently floats through. The universe is, by almost any measure we can devise, empty. Staggeringly, almost incomprehensibly empty. And yet the emptiness itself is not simply an absence, it is a presence. It shapes us. It defines the distance between everything we love and everything we have ever dreamed of reaching. Tonight, we are going to drift through that emptiness together, slowly, quietly, without urgency. If you find your thoughts softening as we go, if your eyes grow heavy, let them. This is a place where you are allowed to rest. And if you would like to return to quiet journeys like this one, a gentle tap of the subscribe button is all it takes. Nothing more is asked of you tonight. Let us begin with a number that almost no one truly grasps. The nearest star to our Sun, a small red dwarf called Proxima Centauri, sits roughly 4.24 light-years from Earth. That sounds almost approachable. 4 is a small number. We count to 4 without thinking. But a light-year is the distance light travels in 1 year, and light moves at about 300,000 kilometers every second. So 4.24 light-years is roughly 40 trillion kilometers. If you built a highway from our Sun to Proxima Centauri, and you drove along it at 100 kilometers per hour without ever stopping for fuel, for food, for sleep, you would arrive in roughly 45 million years. The first members of our genus, Homo, would not even exist for another 42 million years after you set out. You would pass no gas stations, no rest stops, no other travelers.
For 45 million years, there would be nothing beside your windows but darkness and the occasional distant glint of a star so far away it might as well be painted on the sky. This is the first thing the universe teaches us. The spaces between things are not incidental. They are the main feature. Consider our own solar system, which we often picture as a tidy little neighborhood. The familiar diagram shows the Sun with its planets arranged around it like beads on a necklace. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Cozy, orderly. But that diagram is a lie, as all such diagrams must be, because if you drew the solar system to scale on a single page, the planets would be invisible. They would be smaller than the ink molecules in the paper. If you shrank the Sun to the size of a grapefruit and placed it on a table, Earth would be a grain of sand about 15 meters away. Jupiter would be a small marble nearly 80 meters from the grapefruit, and Neptune, that pale blue outermost giant, would be a smaller marble nearly half a kilometer down the road. Between these tiny specks, there would be nothing. No asteroid belt you could see without a microscope. No dust you could notice. Just a table, impossibly long, with almost nothing on it. The Voyager 1 spacecraft, launched in 1977, is humanity's farthest emissary. It left Earth when disco was still playing on the radio. It swung past Jupiter, past Saturn, and continued outward, gathering speed from gravitational slingshots, sailing into the darkness at roughly 61,000 kilometers per hour. As of this moment, it is more than 24 billion kilometers from home, which is about 162 astronomical units, where 1 astronomical unit is the distance between Earth and the Sun. It has been traveling for nearly 5 decades,
And if it were aimed directly at Proxima Centauri, which it is not, it would need another 70,000 years or so to arrive. 70,000 years.
Longer than written language has existed, longer than agriculture, longer than the last ice age. That is the distance to the nearest star. And the nearest star, as stars go, is absurdly close. Pause with that thought for a moment. The Milky Way, our home galaxy, contains somewhere between 100 billion and 400 billion stars. No one knows the exact figure, because counting stars in a galaxy is a bit like counting grains of sand on every beach on Earth while standing on one of those beaches. The Milky Way is roughly 100,000 light-years across. If you could somehow travel at the speed of light itself, the maximum speed permitted by the laws of physics, it would still take you 100,000 years to cross it. And yet, within that vast disk, the stars are spread out so thinly that if you shrank each star to the size of a grain of sand, the nearest grain to ours would be several kilometers away. The Milky Way, seen from inside the scale of its own contents, is mostly nothing. This is the second thing the universe teaches us. Even a galaxy, that beautiful pinwheel of light we paint on posters and tattoo on our arms, is more empty than full, far more. The bright spiral arms you see in photographs are statistical illusions, regions where stars are slightly more concentrated than elsewhere. But even within those arms, the gaps between stars remain immense. A galaxy is less a city than a cathedral with a few candles lit in the far corners. And here is where the emptiness deepens, because the Milky Way is only one galaxy. The observable universe contains, by current estimates, something on the order of 2 trillion galaxies. 2 trillion. Each one holding anywhere from a few million to a few trillion stars. The numbers quickly become meaningless to a human mind, which is part of why I am walking you through them slowly. We did not evolve to intuit such scales. We evolved to notice rustling grass and ripe fruit and the faces of our children. We are very good at the things that kept our ancestors alive. We are not good at galaxies, but we can feel them, even if we cannot count them. Between galaxies, the emptiness becomes something altogether different. The Milky Way and the Andromeda Galaxy, our nearest large neighbor, are separated by about 2.5 million light-years of nearly perfect vacuum. Nearly perfect, but not quite. In that intergalactic space, the average density of matter is roughly 1 atom per cubic meter. Think about that. 1 atom. In a box the size of a refrigerator, there would be, on average, a single hydrogen atom drifting through it. Compare that to the air you are breathing right now, in which every cubic meter holds something on the order of 25 sextillion molecules. The space between galaxies is more empty than the best vacuum any laboratory on Earth has ever produced. By factors so large they break comparison. And yet the stars exist, and yet we exist. Somehow, in all this emptiness, something coalesced, something ignited, something learned to look back at the sky. Let us slow down now. Let your breathing slow with me. The journey becomes quieter from here. There is a place, far from any galaxy, that astronomers call a void. The universe, it turns out, is not simply scattered with galaxies at random. Galaxies cluster. They form threads and sheets and filaments, a kind of cosmic web drawn out over hundreds of millions of light-years. Between these filaments lie vast bubbles of nothing. These are the voids. The largest known void, the Bootes void, is roughly 330 million light-years across. Within that enormous volume, there are only a few dozen galaxies,
scattered so thinly that if our Milky Way were at its center, we would not have discovered that other galaxies existed until well into the 20th century, because we would have seen almost nothing through our telescopes.
An inhabitant of a world in the Boötes void, looking up at the sky, would see only a handful of dim smudges. Darkness mostly. A sky like the inside of a cave. There is something almost unbearable about the idea of such voids, and yet also something clarifying, because they remind us that even emptiness is not uniform. The universe does not distribute its nothing evenly. Some parts of the cosmos are more nothing than others. The voids are the deepest silences in a song already built mostly of silence. If you could somehow travel to the center of the Boötes void and look in every direction, you would see an almost unbroken darkness. The faint, scattered galaxies within would be too dim and too distant to form any real pattern. It would be like standing in the middle of the ocean at night, with no stars overhead, no shore, no compass, only the soft lapping of waves that are themselves only an idea. And yet, even there, the cosmic microwave background would still be present. Even there, the faint hum of the early universe would continue to pass through, carrying the oldest light that exists. Even in the emptiest place we know of, the universe has not forgotten itself. It simply remembers more quietly. The astronomer Robert Kirshner, who helped bring attention to such voids in the 1980s, once described them as the largest known structures in which there is almost nothing to see. A wonderful phrase when you sit with it. Structures of absence, shapes made of missing things. A new kind of geometry, not of what is there, but of what has chosen not to be. We, by contrast, were born in a relatively crowded neighborhood. The Milky Way sits within what is called the local group, a modest cluster of about 80 galaxies bound together by gravity. The local group is itself part of the Virgo supercluster, which is part of an even larger structure called Laniakea, a Hawaiian word meaning immeasurable heaven. Laniakea contains about 100,000 galaxies, all drifting slowly toward a point called the Great Attractor, whose exact nature remains partially hidden behind the plane of our own galaxy. Even here, where galaxies are relatively close to one another, the emptiness between them dwarfs anything we experience on Earth. The feeling this ought to produce, and often does, is one of smallness. But smallness is not the same as insignificance. This is something worth sitting with for a moment. A single candle in a vast cathedral is not less beautiful because the cathedral is large. It may, in fact, be more precious. The emptiness around a thing is part of what makes the thing visible at all. There is an idea that comes from the early 20th century, from a paradox named after the German astronomer Heinrich Olbers, though others had considered it before him. The paradox goes like this. If the universe were infinite and eternal and filled evenly with stars, then no matter where you looked in the night sky, your line of sight would eventually land on the surface of a star. Every point of the sky would be as bright as the sun. The night would not be dark. It would be a wall of fire. And yet the night is dark. Beautifully, emphatically dark. Olbers' paradox tells us something profound, something that took a long time for science to fully absorb. The darkness of the night sky is itself evidence, evidence that the universe had a beginning, that it is not infinitely old, that it is expanding, stretching the light of distant objects into wavelengths our eyes cannot see. The darkness between the stars is a kind of cosmic memory, a record of time itself. When you look up at a dark sky tonight, if you have one available, or simply imagine one, remember that the darkness is not empty of meaning. It is telling you the age of the universe. It is telling you that space is growing. It is telling you that light, even traveling at the fastest speed physics allows, has not had time to fill every corner. The universe is roughly 13.8 billion years old. That is the current best estimate, derived from multiple independent lines of evidence. 13.8 billion years ago, everything we can observe today was compressed into a state so hot and dense that our equations begin to fail. From that unimaginable beginning, space itself began to expand, and it has been expanding ever since. And the expansion is not slowing down, it is accelerating. Something which we have named dark energy, for lack of any better understanding, is pushing the universe apart faster and faster, which means the emptiness is growing. Every second, the distances between galaxies increase. Every second, the night becomes a little emptier than it was the second before. There is a quiet sadness in this, and also a quiet peace. The universe is not a static stage. It is a process, a slow unfolding. And we, improbably, are here to witness a particular chapter of it, a chapter in which galaxies are still visible to one another, in which the night sky still holds light from places and times far removed from our own. In the deep future, trillions of years from now, the accelerating expansion will carry most galaxies beyond the reach of any telescope, no matter how powerful. Civilizations born in that era, if any exist, will look up and see only their own galaxy, alone in the dark, with no evidence that anything else ever existed. They will have to reconstruct the history of the universe from first principles, or perhaps believe their galaxy is all there ever was. We are among the lucky ones. We were born early enough to see. Let us drift a little deeper now into the texture of the emptiness itself. Because the vacuum of space, as it turns out, is not truly empty in the way our everyday intuition suggests. It is not nothing. It is something very strange indeed.
When physicists look closely at what we call a vacuum, they find that it hums. Not with sound, of course, because sound requires a medium, but with activity, with fluctuation. The laws of quantum mechanics forbid any region of space from being perfectly, absolutely empty, because even a true void would require knowing both the energy and the duration of that emptiness with perfect precision, and such precision is not permitted in our universe. So the vacuum seethes. Particles and their antiparticle counterparts flicker into existence in pairs, and then annihilate one another, over and over, at every point in space, at every moment in time. These are called virtual particles, and while they cannot be observed directly, their effects can be measured. They subtly shift the energy levels of atoms. They give rise to a tiny but measurable force between closely spaced metal plates, a phenomenon called the Casimir effect, predicted in 1948 and confirmed in laboratories decades later. So even the most perfect vacuum you can imagine is alive with a kind of quiet, restless ghosting. The emptiness is not inert, it trembles. This is worth letting settle in your mind for a moment, as your breathing slows, as the room around you grows still. The nothingness between the stars is not a void in the old sense of the word. It is a medium, a thin, strange medium full of fields and potentials and possibilities that never quite resolve into permanent form. And there is more, far more than the virtual particles, because the vacuum of space also contains the thing we call dark matter, which is not really dark in the way a dim room is dark, but rather invisible in the sense that it does not interact with light at all. It neither emits nor absorbs nor reflects electromagnetic radiation. It is transparent to every telescope we have ever built or could ever build along those lines. And yet it is there. We know it is there
because galaxies rotate in ways that should, by the rules of ordinary gravity, tear them apart. The outer stars of a spiral galaxy orbit the center too quickly to be held in place by the gravity of the visible matter alone. Something else must be holding them, some invisible scaffolding, some unseen mass roughly 5 to 6 times more abundant than the ordinary matter we are made of, spread through every galaxy and between galaxies in great invisible halos. Dark matter is everywhere. It is passing through you right now, in quiet multitudes, without so much as a ripple. Every second, an uncountable number of dark matter particles, whatever they are, drift through your body, through your bed, through the earth itself, as if none of it were there. The earth is essentially transparent to them. We are living inside a sea of something we cannot see, cannot feel, cannot touch, and whose nature remains one of the great unsolved questions of physics. And then there is dark energy, which is stranger still. Dark energy is the name given to whatever is causing the expansion of the universe to accelerate. It appears to be a property of space itself, a kind of faint pressure that pushes outward, growing stronger as more space comes into existence. Roughly 68% of everything in the universe, by mass and energy, is dark energy. Another 27% is dark matter. Only about 5% is ordinary matter, the kind that makes stars and planets and oceans and bodies and dreams. 5%. That is the slice of the universe that looks the way we expect things to look. Everything else is mystery. It is worth pausing here to appreciate how recently we learned any of this. The idea that the expansion of the universe is accelerating was confirmed only in 1998 by 2 independent teams studying distant supernovae.
Before that, most cosmologists assumed the expansion was slowing down, held back by gravity, perhaps even destined to reverse one day in a great collapse. The discovery came as a genuine surprise. It upended decades of assumption, and it opened a question we have not yet answered and may not answer for generations or ever. What is dark energy? We do not know. We have names for it. We have equations that describe its behavior. We have measured its magnitude with great precision, but we do not know what it is. There is a certain humility required to live alongside such a fact. The thing that dominates the energy budget of the cosmos, the thing that determines the ultimate fate of everything, is a mystery we cannot yet penetrate. We share the universe with it. We move through it. It shapes the sky above us, and we do not know its name. This should not feel like a failure. It should feel like an invitation. The universe has saved some of its best questions for minds that have not yet been born. There will be astronomers in the centuries ahead who look back at our era the way we look back at pre-scientific times, with a kind of tenderness for how little we knew, and also how much we already sensed. They will know things we cannot currently imagine. They will have answered questions we can barely frame, and they, in turn, will leave mysteries for those who come after them. The cosmos is generous with its puzzles. There is always more to find. When you consider this, the word empty begins to feel less accurate. The universe is not empty. It is full of things we do not understand. The light we can see, the stars we can photograph, the galaxies we can map. These are only the decorations on a far deeper structure we are only beginning to glimpse. Let us return for a moment to the question of what all this emptiness means for us, because that is why you are here, perhaps, drifting through these ideas as sleep begins its gentle approach. We are a species that evolved on a small, warm planet, orbiting an average star,
near the edge of one arm of one galaxy, in a universe so vast that our entire recorded history is a blink. Our entire species is a whisper. Our entire planet is a mote of dust. By any reasonable measure, we should feel crushed by the scale of this. And yet, many who think deeply about cosmology report the opposite. They describe a sense of peace, a loosening of the grip of everyday worries, a quiet recognition that the things that feel enormous in our daily lives, the deadlines and disappointments and slights and fears, are held within a container so large that they soften simply by being placed inside it. There is a word for this feeling used in some philosophical traditions. Awe. Not fear, not dread, awe. The response of a mind encountering something larger than itself and recognizing for a moment its own smallness, and finding in that recognition not humiliation but relief. The universe is terrifyingly empty only if you believe we were supposed to be the center of it, only if you hold, somewhere in your mind, the expectation that the cosmos ought to be crowded with meaning for our convenience. Once that expectation loosens, the emptiness becomes something else. It becomes room. Room for light to travel, room for galaxies to turn, room for planets to form and cool and gather oceans. Room for life to emerge, not because the universe demanded it, but because in an immensity this large, even the unlikely eventually happens. We are the unlikely, and the unlikely is not less precious for being improbable. It may be more so. Let your attention drift now, slowly, out beyond the walls around you, past the city or the town or the quiet countryside where your body rests, past the thin skin of the atmosphere, past the moon, a companion so close we can see its face, and yet still roughly 384,000 kilometers away. Past the other planets, each one a world unto itself, with landscapes no human eye has ever seen in person. Past the outer solar system, where the Voyager spacecraft continue their slow journey into the dark. Past the Oort cloud, that hypothetical sphere of icy bodies that marks the outermost edge of our sun's gravitational domain, extending perhaps as far as 100,000 astronomical units from home. Past even that, into the true interstellar medium, where the light of our sun fades into just another distant point among billions. Out here, the emptiness is not frightening. It is vast and patient. It has been vast and patient for billions of years. It will continue to be vast and patient long after any of us are gone. There is a strange comfort in this. The universe does not hurry. The universe does not worry. The universe simply is, and expands, and goes on being. Consider the interstellar medium more carefully. In the space between stars within our galaxy, the density of matter averages roughly 1 atom per cubic centimeter. That is denser than the intergalactic void by a considerable margin, but still unimaginably thin. A cubic centimeter is about the size of a sugar cube. Fill that space with a single atom and leave the rest as nothing, and you have a fair sample of the interstellar medium. If you were floating out there with some impossible suit that kept you alive, you could hold out your hand and know that, on average, your hand would pass through only a few atoms per second. You would be, in every meaningful sense, alone with yourself. The light of distant stars would reach you. The occasional cosmic ray might pass through you. But the great silence of space would press in from every direction, not malevolently, not even indifferently, but simply. The silence of something that does not know you are there and does not need to.
Some of that silence has a music of its own, though we can only hear it with instruments.
The universe is full of radio waves from ancient processes, from pulsars spinning with atomic precision, from the cold remains of galaxies that have moved on. There is a particular whisper, barely above absolute zero in temperature, that bathes every point in space. We call it the cosmic microwave background. It is the light of the universe itself, released when the first atoms formed, about 380,000 years after the Big Bang. Before that moment, the universe was too hot and dense for light to travel freely. Photons bounced endlessly off charged particles, like sunlight trapped in fog. Then the universe cooled enough for electrons and protons to combine into neutral atoms, and suddenly the fog lifted. Light streamed outward for the first time. That light has been traveling ever since, for roughly 13.8 billion years, stretched by the expansion of space into microwaves so faint that they register as a temperature of only about 2.7 degrees above absolute zero. Every direction you look, the cosmic microwave background is there. It is the oldest light in the universe. It is the echo of the beginning, and it fills, very faintly, every cubic meter of the supposedly empty space around us. Right now, billions of those ancient photons are passing through the room where you rest. They have traveled nearly the entire age of the universe to arrive, just now, at this moment, while you breathe, while your thoughts slow, while the world outside your window continues its quiet turning. That is not nothing. That is a universe full of memory, passing through you all the time, without a sound. Consider, too, what happens at the other extreme of cosmic emptiness. Not the great voids between galaxies, but the points of nearly infinite compression we call black holes. A black hole is, in a strange sense, the opposite of emptiness. It is where emptiness has been folded in on itself so tightly that space and time lose their ordinary meanings. And yet, black holes are mostly empty as well, because the matter that falls into them is compressed, according to our best current understanding, into a region so small that the distance between its parts becomes meaningless. The nearest known black hole to Earth is called Gaia, BH1, discovered only in 2022, sitting about 1,560 light-years from our Sun. That sounds very far, and it is, by any human measure. But in galactic terms, that is just around the corner. It was hiding in plain sight, detectable only because of the way it perturbs the motion of a companion star, swinging that star around an invisible partner in a slow, graceful dance. At the center of our galaxy sits a far larger black hole called Sagittarius A star, with a mass roughly 4 million times that of our Sun. It is about 26,000 light-years from Earth, and it is the quiet, gravitational anchor around which the entire Milky Way rotates. Everything we see in the night sky, every constellation, every drifting star, is slowly circling this unseen heart of the galaxy. Our Sun takes about 230 million years to complete one orbit around it. The last time we were in this same position, relative to the galactic center, dinosaurs had not yet evolved into their most famous forms. The next time we return to this point, our species will almost certainly no longer exist. There is a peculiar peace in that thought. The galaxy turns on timescales so vast that even the rise and fall of species is only a single note in its music. We are a note. We are a brief, warm note. And that is not a diminishment. A note does not need to last forever to be beautiful. It needs only to be played. Consider, too, the other extremes the universe has made room for. Consider a neutron star. When a massive star exhausts its nuclear fuel and collapses, its outer layers blow outward in a supernova, while its core compresses with such force that electrons and protons are crushed together into neutrons. What remains is an object roughly the mass of our Sun, compressed into a sphere perhaps 20 kilometers across. A single teaspoon of neutron star material would weigh, if you could somehow bring it to Earth, about 1 billion tons. The matter is packed so tightly that atoms no longer exist in any recognizable form. And these objects spin. Some of them spin hundreds of times per second, their magnetic fields generating beams of radiation that sweep across the cosmos like lighthouses. We call them pulsars. The first pulsar was discovered in 1967, and at first, the regularity of its signal was so strange that the discoverers briefly wondered if they had picked up an alien transmission. They labeled it LGM-1 for Little Green Men. It turned out to be natural, a corpse of a star, dense beyond imagination, spinning in the darkness, beaming energy into the void. And yet, improbable as they are, neutron stars are everywhere. The galaxy contains, by best estimates, perhaps 100 million of them. Each one the quiet tombstone of a star that lived and died long ago. Each one a reminder that matter itself can be compressed into states we can barely describe, spinning silently, sending their signals outward, whether or not anyone hears. Consider also the places where new stars are born, stellar nurseries. Clouds of gas and dust, light years across, slowly collapsing under their own gravity. The Orion Nebula, visible as a faint smudge in the sword of the constellation Orion, is one such nursery, about 1,344 light-years from Earth. Inside it, right now, new stars are igniting. New planetary systems are forming. New possibilities, new futures. New worlds are being drawn out of raw material that has drifted in space for hundreds of millions of years. Some of those stars, when they look out into the cosmos in a few million years, will see our own Sun as an ancient background feature of their sky. Some of them may have planets. Some of those planets may someday have oceans. Some of those oceans may someday have life. And none of it will know about us, as we do not know, really, about any of them. This is the fertility of the universe. Not the fertility we usually think of in the sense of warm bodies and growing things. A different fertility, a cosmic one. The universe keeps making new stars. It has been making them for more than 13 billion years, and it will continue making them at slower and slower rates for many billions more. The universe is not a finished thing. It is an ongoing act. We have arrived partway through a performance that will continue long after our own story has ended. There is a phrase that astronomers sometimes use when describing the fates of things in the cosmos. They speak of deep time. Not the time of history or geology, though geologic time already stretches our intuitions past their natural limits. Deep time is the time of stars, the time of galaxies, the time of the universe considered as a whole. In deep time, our Sun is a middle-aged star, about 4.6 billion years old, with perhaps another 5 billion years left before it swells into a red giant and consumes the inner planets. In deep time, the universe is still young. There are stars forming right now in dense clouds of gas and dust scattered throughout the Milky Way. Stars that will not ignite for another 100,000 years. There are planets condensing out of protoplanetary disks, planets that will be ancient ruins by the time any intelligent species evolves to notice them.
It is worth lingering on the concept of deep time a little longer.
Because most of us, even those who read science, still carry a lingering sense that the universe operates on human scales. It does not. It operates on its own scales, and they are almost indescribable. If you compressed the entire history of the universe into a single calendar year, with the Big Bang on January 1st and the present moment at midnight on December 31st, then our sun would not form until late August. The Earth would coalesce a few days later. The first single-celled life would appear in late September. Multicellular organisms would emerge in November. Dinosaurs would walk the Earth during the last week of December. The asteroid that ended their dominance would strike around December 30th. Human beings, our species in its anatomically modern form, would appear in the final 12 minutes before midnight on December 31st. Recorded history would occupy roughly the last 14 seconds of the year. Your own lifetime, whatever its length, would fit inside less than a quarter of a single second of that cosmic calendar. And yet your quarter second is real. Your quarter second contains entire universes of feeling, first loves and last goodbyes, warm afternoons and long nights, the taste of a meal someone cooked for you with care, the sound of rain against a window you lay beneath as a child. Your quarter second is so small on cosmic scales that it barely registers, and yet within it, the cosmos has invented something new: experience, memory, a subjectivity that knows itself to exist. The universe, for all its vastness, did not have this for most of its history. Whatever consciousness is, however it arises, it is a late addition to reality, and one of the rarest ingredients the universe has so far produced. Every moment you are aware, you are part of a very small, very recent experiment in the cosmos knowing itself. Let that sit gently, not as a burden, as a quiet privilege. And in deep time, the emptiness will grow. The accelerating expansion will carry things apart faster than gravity can pull them together on the largest scales. Eventually, across unimaginable spans of time, galaxies themselves will begin to unravel. Stars will exhaust their nuclear fuel. Black holes, those quiet devourers of matter and light, will grow and merge, and eventually, through a process so slow it almost defies belief, evaporate through the emission of Hawking radiation, vanishing over spans of time so long they cannot be meaningfully written in ordinary numbers. The universe of the far future will be colder, darker, emptier than anything we can truly picture. A sea of fading light, dispersing into a uniform near-nothingness. This is sometimes called the heat death of the universe, though heat is the wrong word. It is more accurately a cold death, a slow settling into a state where no energy can flow from one place to another, where no interesting process can occur, where time itself becomes almost meaningless because nothing changes anymore. But that future is far away, almost indescribably far, and we are not there yet. We are here, in an era of the universe when stars still shine, when galaxies still rotate, when planets still form, when light from distant objects still reaches observers like us. We are here in the lit hours of the cosmos, as it were. The morning of existence, in a certain sense, though the morning is already billions of years old. This is where the emptiness becomes, for many people, something close to a spiritual thing. Not in the sense of any particular religion, but in the older sense of the word, the sense that predates doctrine, the sense of encountering a reality so much larger than ourselves that the ordinary categories of our lives briefly fall away. We are small, yes. The universe is vast, yes. And yet we are here. We are the part of the universe that, at this particular moment, on this particular planet knows that the universe exists. That is not a small thing. That is, in fact, perhaps the strangest and most unlikely thing of all. A universe that is 95% made of substances we cannot identify, that is filled with a vacuum that hums with virtual particles, that stretches across dimensions we can barely measure, has somehow, in at least one small corner, given rise to minds. Minds capable of doing mathematics, minds capable of asking why, minds capable of looking up at the darkness and wondering what it means, minds capable of drifting off to sleep while contemplating the scale of reality and finding, somehow, that the scale soothes rather than terrifies. Let that soothing continue now. Let the numbers blur a little. It is all right if you cannot hold every figure in your mind. The figures are only there as footholds. The real journey is the sense of size, the sense of quiet, the sense of being one small, warm life inside a cathedral whose walls extend beyond any measurement. The Andromeda Galaxy, our nearest large neighbor, is approaching us. Did you know this? Among the rare cases in which cosmic expansion is overcome by local gravity, the Milky Way and Andromeda are drawn toward each other. In roughly 4.5 billion years, they will begin to merge. The two great spiral galaxies will pass through one another, their stars sliding past each other in the enormous voids between them, almost never colliding because the spaces are too large. But gravity will pull and stretch and tear, and eventually, over the course of billions more years, the two galaxies will settle into a single, larger, elliptical galaxy, sometimes called Milkomeda in playful anticipation. The Earth, if it still exists in any meaningful form, will see the night sky transformed during that long encounter. Andromeda, now a faint smudge in the constellation of the same name, will grow larger and larger until it fills half the sky, a vast spiral visible in unimaginable detail, a neighboring city of stars drawing closer with each passing million years. No human alive today will see this. No human will ever see this, most likely, because by then, the sun will have begun its expansion into a red giant, and Earth as we know it will be a memory. But the event will happen regardless. It is already happening, in a sense. The two galaxies are on their approach right now, traveling at something like 110 kilometers per second toward each other. The dance has already begun. We are simply too early to see the main act. And this is another thing the emptiness teaches us, patiently, if we let it. We are witnesses to a process that does not need us. That would occur whether or not anyone watched. That has been occurring since long before our species emerged, and will continue long after our species is gone. There is a kind of freedom in that, a kind of lightness. The universe is not a performance staged for our benefit, and when we release the idea that it ought to be, the universe becomes something more honest, more beautiful, and somehow more gentle. Let us drift now into the softest part of our journey, the part where the ideas settle like snow, where the numbers stop mattering quite so much, where what remains is simply the feeling of being held within something enormous and ancient and kind in its own distant way. Imagine for a moment the Earth seen from very far away. Not from the moon, though that view alone has moved astronauts to tears. Not from Mars, where our small rovers have photographed our world as a pale dot in the Martian sky. But from farther still, from the outer solar system, where in 1990, the Voyager 1 spacecraft, already more than 6 billion kilometers from home, turned its camera back for one last look before its instruments were shut down to conserve power. The image it captured is sometimes called the pale blue dot. Earth appears as a single pixel, suspended in a thin beam of scattered sunlight, a speck so small that most people, on first seeing the image, cannot find it without being shown where to look. And yet that speck contains every person who has ever lived, every war ever fought, every love ever felt, every song ever sung, every goodbye, every quiet morning with a cup of tea, every child's first word, every grandmother's last breath, all of it on one dot, 6 billion kilometers away, barely visible against the great dark. The astronomer Carl Sagan, who urged Voyager to take that photograph, spent much of his life thinking about what such an image might mean. He wrote about it with a gentleness that still echoes. The pale blue dot, he observed, shows us our home, our entire home, reduced to a mote in a sunbeam. Everything we are, everything we have been, everything we hope to become, all of it there on that tiny point in the vast ocean of space. And the ocean continues outward from that dot, growing quieter and larger with every step, out past Neptune, out past the scattered disk of icy bodies, out into the heliosheath, where the sun's particles finally slow against the pressure of interstellar matter. Out through the heliopause, that invisible boundary where the sun's influence gives way to the broader galactic environment. Voyager 1 crossed that boundary in 2012. For the first time, a human-made object left the bubble of our star's reach and entered truly interstellar space.
It has been drifting through that larger sea ever since, sending back faint signals that grow fainter every year, until someday, not long from now as such things go, the signals will cease, and Voyager will continue on in silence. A small metallic ambassador carrying a golden record of Earth's sounds and images, destined to drift for millions, perhaps billions of years, almost certainly never to be found by anyone. There is a quiet beauty in that, a message in a bottle cast into an ocean so large the bottle may never touch another shore. And yet we sent it. We made that gesture. A species that has existed for only a flickering moment, on a planet that is itself a blink in the age of the universe, reached out anyway. Because that is what we are. Creatures who gesture outward. Creatures who make marks and leave them. Creatures who look at the vast emptiness and, rather than recoil, put something of ourselves into it, however small, however unlikely ever to be noticed. The emptiness of the universe, in the end, is not a verdict against us. It is a context for us. It is the silence in which our small signals play. Without the silence, the signal would have no meaning. Without the darkness, the light would have nowhere to shine. The stars are beautiful not in spite of the black sky, but because of it. The galaxies are beautiful because they are set against nothing. Our small, warm lives are beautiful because they are improbable, brief, and held within an immensity that could have been otherwise, but happened to include us anyway. Let us stay here for a while, in this quiet. There is a moment that many astronomers describe after years of studying the cosmos, when the weight of the numbers gives way to a kind of simplicity. The figures remain true, the scales remain real, but something shifts. The mind stops resisting the size of things. It accepts, it settles, and in that settling, an odd warmth arises. The universe, which seemed so cold and so vast, is not less vast, but somehow, mysteriously, not cold either. It is simply large, and we are simply small, and both of these facts can sit side by side without one overpowering the other. This is, perhaps, the gift of thinking about emptiness long enough. Not a conclusion, not a belief,
just a kind of quiet permission to stop needing the universe to be other than it is. The night sky you can see from Earth contains roughly 9,000 stars, visible to the unaided human eye, under ideal conditions, combining the views from both hemispheres. Only a few thousand of those are visible from any single point on any given night. Those few thousand pinpricks are what our ancestors saw. It is what every human in every generation has looked up at, from the first nomadic bands who noticed patterns and named them, to the ancient astronomers of Babylon and Egypt and India and China, to the medieval stargazers, to us. We are all looking at mostly the same sky. The patterns have drifted only slightly over tens of thousands of years. The constellations you see tonight, if you step outside and look up, are very nearly the same constellations that looked down on the first campfires of our species. Every one of those stars is a sun. Every one of those suns may have planets. Some of those planets, almost certainly, have oceans or skies or weather we will never see. Some of them, though we do not know this for sure, may have something alive upon them, something that looks up, as we do, at their own version of a night sky, something that wonders, as we do, what all this space is for. For most of human history, we had no proof that other stars even had planets. We assumed they did. It seemed natural. But assumption is not evidence, and the question remained open for thousands of years. Then, in 1992, astronomers confirmed the first planets around another star, a pulsar called PSRB 1257+12.
3 years later, in 1995, the first planet around a sun-like star was discovered, a gas giant orbiting 51 Pegasi, about 50 light-years from Earth. Since then, the catalog has grown relentlessly. We now have confirmed detections of more than 5,500 exoplanets, and the real number across the galaxy is estimated in the hundreds of billions. Nearly every star, it seems, has at least one planet. Many have several. Some have systems more complex than our own. So when you look up at the night sky, know that nearly every pinprick of light has worlds circling it. Some are molten. Some are frozen. Some are gas giants larger than Jupiter. Some are small rocky worlds, not unlike Earth. A few of them, a small but non-zero number, orbit within the region where liquid water might exist on their surfaces. We do not yet know if any of them are alive. We are only beginning to develop the tools to check. And here rises one of the strangest and most beautiful questions of modern science. The question known as the Fermi paradox, after the physicist Enrico Fermi, who once asked during a casual lunchtime conversation in 1950, "Where is everybody?" The galaxy is old. The galaxy is full of stars. The galaxy is full of planets. If life is common, and intelligence is at least occasionally the outcome of life, then the galaxy should have been colonized, explored, filled with signals many times over by now. And yet we see nothing. We hear nothing. The skies are silent. Every sensitive radio telescope we have aimed at likely candidates has come back with the same answer: nothing. Or at least, nothing we can recognize. This silence is sometimes called the Great Silence, and it is one of the most unsettling features of our universe, because there are so many possible explanations, and we cannot yet distinguish between them. Perhaps life is incredibly rare. Perhaps intelligent life is rarer still.
Perhaps civilizations tend to destroy themselves before they reach the stars. Perhaps they transcend into forms we cannot detect. Perhaps they are all around us, but so different from us that we do not recognize their signals as signals. Perhaps we are listening at the wrong frequencies, with the wrong assumptions, in the wrong decades of the galactic year. Perhaps we are simply alone. Each of these possibilities has its own shape, its own weight,
and each asks us to hold a different relationship with the cosmos. If we are alone, we are the only voice the universe has. If we are not alone, we are merely one voice among many, unable, at least for now, to hear the others singing. Both possibilities are strange. Both are humbling, and both rest on the same underlying fact. The universe is so large and so empty that even a galaxy full of life could feel, from the inside, like a galaxy of solitude. We will probably never meet them. The distances are too great, the times too long, the chances of our existences overlapping too small. The universe is so arranged that even if life is common, its instances may be forever separated from one another by the sheer scale of the space between. This might sound lonely, and in a certain mood it is. But in another mood, it is something gentler. Each world gets to be its own quiet theater. Each consciousness gets to discover the cosmos freshly, without borrowed answers. Each planet of thinking beings, if any such planets exist, has to work out for itself what the stars mean. The universe has enough room for all of them, enough room that none need crowd against another. The emptiness is also a kindness. It is the reason there is space for us. Consider, too, what all of this does to the ordinary worries of an ordinary day. The things we carry with us into bed, the small aches of the mind, the unfinished conversations, the concerns about tomorrow. These things are real. They matter.
A human life is made of such things, and the cosmos does not dismiss them. But the cosmos does offer a kind of wider canvas against which they can be seen. When you know that the light reaching your eyes from a star overhead began its journey before your grandmother was born, the urgency of your inbox softens just a little. Not because your life is unimportant, but because your life is part of something whose timescales are generous. There is time for things to settle. There is room for things to be unresolved. The universe has been unresolved for nearly 14 billion years and has not collapsed from the weight of open questions. You may extend yourself the same patience. There is another thought worth pausing with on this slow drift toward sleep. The thought of how fragile and improbable our view of the universe actually is. Not just that we exist, but that we can see as far as we can see. The observable universe, the portion of the cosmos from which light has had time to reach us since the beginning, has a radius of about 46 billion light-years in every direction. This is already an almost incomprehensible number. But the observable universe is not the whole universe. It is only the part of the universe we can, in principle, observe. Beyond it, there is almost certainly more. Perhaps much more. Perhaps infinitely more. We cannot know. Light from those regions has not had time to reach us. It may never reach us, because the expansion of space carries distant regions away from us faster than their light can cross the gap. This means that somewhere beyond our visible sphere, there may be entire systems of galaxies, entire webs of structure, entire epochs of history that we will never see. Not because they are hidden, but because the universe is larger than sight itself. There is a term for the edge of our visible sphere. It is called the cosmological horizon. And this horizon, unlike the horizon of the ocean, is not a limit that recedes as we approach it. It recedes faster than we can ever approach it. It is a fundamental boundary, a soft wall made of geometry and time. Everything we will ever see, everything any telescope will ever capture, everything any science will ever measure, lies within this sphere. And beyond it, we can only infer, only imagine, only hypothesize. The unseen cosmos is vastly larger than the seen cosmos, almost certainly, and we make peace with this by recognizing that the visible portion is already so large that no single human mind could exhaust its wonder in 1,000 lifetimes. We do not need to see everything. We need only to see a little, and to see it well, and to feel, in the seeing, the scale of what we are part of. The universe is generous enough that even a partial view is more than enough. There is one more thing worth telling you before the words begin to soften further. A fact that was not available to anyone in human history before the 21st century. A fact we learned by building instruments so sensitive that they can detect ripples in the fabric of space itself. The fact is this: space-time, the combined geometry of space and time that Einstein described in 1915, can ripple. When massive objects accelerate, they send out disturbances in space-time that travel outward at the speed of light. These disturbances are called gravitational waves. For a century after Einstein predicted them, no one could detect them. They were too small. The distortions they caused were far less than the width of a proton across a kilometer-scale detector. But in September of 2015, for the first time, a pair of gigantic interferometers called LIGO registered a signal. Two black holes, each about 30 times the mass of our Sun, had spiraled into one another roughly 1.3 billion light-years away.
Their merger released more energy, briefly, than all the stars in the observable universe combined, but in a form our eyes could never see. It was a silent, invisible scream in the geometry of space-time, and it rang across the cosmos for over 1 billion years before it reached Earth, passing through our planet on its way to the rest of the universe, leaving behind only the faintest whisper that our instruments could barely hear. We are now listening to the universe in this new way. Gravitational waves have become a kind of second ear alongside the eye of light. We hear black holes merge. We hear neutron stars collide. We hear, occasionally, events whose sources we do not yet understand. The cosmos, it turns out, is not silent. We simply could not hear it until recently. There is another instrument worth mentioning here because of what it has shown us about the distant past. In December of 2021, after decades of planning and setbacks, we launched the James Webb Space Telescope. It traveled about 1.5 million kilometers from Earth to a gravitationally stable point called Lagrange Point 2, where it now drifts in a slow loop, shielded from the sun, its giant gold-coated mirror unfolded like a flower, peering into the infrared portion of the spectrum that our eyes cannot see. Within months of its first observations, it returned images that rearranged our understanding of the early universe. Galaxies that should not have existed so soon after the Big Bang. Structures too mature for their age. Colors and compositions that asked new questions about how quickly matter organized itself into stars, and how quickly those stars organized themselves into communities. The light reaching Webb from those distant galaxies has been traveling for more than 13 billion years. When we see those galaxies, we are seeing them as they were when the universe was less than 1 billion years old. Their current selves, assuming they still exist, are impossibly far away now, pushed outward by cosmic expansion beyond the reach of any direct observation. But their ancient light is still arriving, just now, for the first time in any human history. Think of that. For 13 billion years, those photons were in transit, and during the brief window of our existence, a window thinner than the width of a thread compared to the age of the universe, we managed to build something that could catch them. The timing required for this is almost comically narrow,
And yet here we are, catching photons sent on their journey when the Earth was not yet a coherent thought in the mind of the galaxy. This is one of the strange and beautiful aspects of astronomy. To look deeply into space is to look deeply into time. The night sky is a kind of museum of the past, with different exhibits at different distances. The sun we see is the sun of 8 minutes ago, because light from the sun takes that long to reach us. The star Sirius, bright in the winter sky, is the Sirius of about 8.5 years ago. The Andromeda galaxy we see is the Andromeda of 2.5 million years ago, the version of it that existed when our distant hominid ancestors were first learning to walk upright on the African savanna. Everything we look at in the sky, we are looking at through a kind of time lag. The farther away, the deeper the lag. And in the deepest images, we are looking at the universe as it was when it was young. In a real sense, we can never see the present state of the distant cosmos. We can only see its past. The now of the universe, whatever that means for places billions of light years away, is invisible to us. What we see is always a memory. The sky is a library of memories, arranged by distance. And when we look at the oldest light, we are reading the first pages of a book whose later pages will not be written for billions of years.
And this is, in a way, the most hopeful thing about living in our particular moment. We are the first generation of humans to listen to the universe with ears we built ourselves. For hundreds of thousands of years, our ancestors looked up and saw only what the unaided eye could show them. Then came telescopes, and the sky opened up. Then came radio astronomy, and we heard the echoes of ancient processes. Then came gravitational waves, and we felt the universe tremble. Each new sense has revealed a cosmos more intricate, more full of hidden detail than the one before. And there will be more senses yet. There will be instruments we have not yet imagined. The sky, which looks the same to the human eye as it did to our great-grandparents, is being continually enriched by our ability to perceive it in new ways. The universe has not changed. We have changed. And in changing, we have found that the universe had always been speaking in languages we could not yet hear. The physicist Freeman Dyson once wrote that the universe is surprisingly hospitable to intelligence in the long run. He imagined minds of the far future, adapted to colder and colder conditions, slowing their thoughts to match the slowing pace of the cosmos, thinking long thoughts across spans of time we would find unimaginable. Whether any such minds will actually exist is unknowable. But the image is a lovely one. Thought continuing even as the stars fade. Awareness adapting to whatever conditions remain. The universe in this view is not merely a place where life briefly flickered and then vanished. It may be a place where some form of awareness accompanies the cosmos all the way down, watching the long twilight with patient eyes. Perhaps that is too optimistic. Perhaps the cold death is truly a death, and nothing of us or our successors survives into the deep future. We do not know. We cannot know yet. And there is peace in that uncertainty too.
We do not have to know the ending to love the story we are living in. Let yourself breathe slowly now, if you are not already. In and out. In and out. Feel the weight of your body pressing gently into the surface beneath you. Feel the small warmth of your own presence, that small candle of aliveness that is you tonight in this room. Around you, the air contains trillions of molecules, each one engaged in its own tiny, ceaseless motion.
Each breath you take pulls some of that air into your lungs, where oxygen molecules, forged inside ancient stars, are absorbed into your blood and carried to every cell in your body. The carbon dioxide you release has been part of you only briefly. Before it was inside you, it was part of something else. A leaf, perhaps, an ocean, a glacier, a whale. The atoms we borrow from the environment do not stay long. Within about 7 years, nearly every atom in your body has been replaced. You are, in a literal sense, not made of the same stuff you were made of a decade ago, and yet you are still you. Continuity, it turns out, is not a matter of unchanging material. It is a matter of pattern. You are a pattern drawn in borrowed atoms persisting through time. The universe, on its own vast scales, is doing something similar. The galaxies we see today are not the galaxies of 1 billion years ago. They have changed. Stars have been born, and stars have died within them. New patterns have emerged. Old patterns have dissolved, and yet the structure remains recognizable. Continuity for a galaxy is also a matter of pattern, not of unchanging substance. Everything flows, nothing stays, and yet somehow things persist. A river is different water every moment, and still the river. A flame is different matter every moment, and still the flame. You are different atoms every few years, and still yourself. This is what the universe does. It makes patterns, and the patterns last while their materials pass through. Sleep, too, is a kind of pattern.
A rhythm your body returns to, night after night, carrying you across hours of time without your conscious witness. Tonight, as every night, you will cross that threshold without effort. You do not have to try. You do not have to work at it. You only have to let yourself drift, as the stars drift, as the galaxies drift, as everything drifts, toward whatever comes next. There is something else worth mentioning, softly, as the mind grows quiet. The solar system we live in is itself a small, warm eddy in the vast currents of the galaxy. The sun, carrying its planets with it, is moving through the Milky Way at roughly 220 kilometers per second. We are not stationary. We have never been stationary. At this very moment, you are riding on the surface of a planet that orbits a star, that orbits a galaxy, that drifts through a cluster, that moves within a supercluster, that is carried along by currents of gravity we do not yet fully understand. And yet, for all this motion, everything around you feels still. The bed beneath you does not seem to be moving. The room does not sway. The window does not rattle from the speed at which the Earth is traveling through space. This is because we are moving with the Earth, and the Earth is moving with the Sun, and the Sun is moving with the galaxy, and in the absence of any fixed reference point outside our own system, the motion is invisible. There is, I think, a quiet lesson in this. So much is happening all the time that we cannot feel. The Earth is turning, the Sun is burning, the galaxy is rotating, the universe is expanding, the atoms in your body are exchanging and replacing themselves. The blood in your veins is moving, the air is filling and leaving your lungs. And through all of this, you can rest. You can lie still. You can let your mind quiet. The motion does not require your attention to continue. It will continue on its own. It always has. The sun, right now, is fusing about 600 million tons of hydrogen into helium every second. Inside its core, temperatures reach roughly 15 million degrees Celsius. Pressures would crush any ordinary material into forms we could not name. And yet for us,
Here on Earth, the sun feels gentle. It rises and sets. It warms our skin. It lights our days. The violence of its interior is transmitted to us only as warmth and light, filtered by millions of kilometers of space, softened into something we can live with. The universe, which contains such ferocity at its core, has arranged itself in such a way that a small creature on a small planet can feel only its kindness. This is not an accident. This is what distance is for. This is what emptiness is for. It absorbs the intensity. It softens the extremes. It lets us exist in the quiet between the storms. The same is true on larger scales. The center of our galaxy, where Sagittarius A star sits, is a turbulent region. Stars orbit at enormous speeds. Jets of material are sometimes flung outward. Energies are released that would be unimaginable closer up. But we live about 26,000 light years away from that center, out in one of the spiral arms, far from the galactic bustle. Our neighborhood is relatively quiet. The sky we see night after night is mostly stable, mostly gentle, mostly the same from one human lifetime to the next. The violence is far away. The emptiness has absorbed it. We have been given a seat in the quiet section of the cosmos, and from that seat we can look up and wonder and rest. Let your breathing soften once more. Let the image of the night sky remain in your mind if you like, but let the numbers fall away. The names of the galaxies, the ages in billions of years, the distances in light years. Let them go. They have done their work. They have brought you here to this still place where the size of the universe no longer requires understanding, only acceptance.
You know what it feels like to be small inside something vast. You know what it feels like to be warm inside something cold. You know what it feels like to be awake inside something that has been asleep for almost all of its existence. These feelings are enough. They do not need to be thought. They only need to be felt. Let your thoughts grow softer now. Let the words become less distinct. Let the ideas blur into the feeling of them, which is what remains when the ideas themselves have slipped below the surface of attention. A universe 95% composed of things we cannot see. A vacuum that trembles with virtual particles. A night sky dark because the universe is young enough to still contain shadows. Galaxies separated by voids the size of imagination itself. A pale blue dot in a sunbeam. A spacecraft drifting, still transmitting, still reaching. An ancient light, 2.7 degrees above absolute zero, passing gently through everything. A local star that has burned steadily for 4.5 billion years and will burn steadily for billions more. A blue world, warm and wet and improbable, where one species, among uncounted species, has learned to name the constellations. You, among that species. Resting now, breathing now, held by gravity to the surface of a spinning planet, which is held by gravity to the star we call the Sun, which is held by gravity to the disk we call the Milky Way, which is held by gravity within the local group, which drifts with all other structures through a universe too large to picture. You are not separate from any of this. The atoms in your body were forged inside stars that lived and died before our sun was born. The iron in your blood, the calcium in your bones, the oxygen you are breathing in and out, all of it was once the interior of a star. When those stars reached the end of their lives and exploded, they scattered their heavier elements into the interstellar medium, where those elements eventually gathered into clouds, and the clouds collapsed into new stars, and around some of those new stars, planets formed. And on at least one of those planets, the atoms found their way into oceans, and into single cells, and into fish,
and into forests, and into creatures that walked, and eventually into you. You are the universe arranged, briefly, into a shape that can think about itself. The emptiness between the stars is in you too, in the vast spaces between the atoms that make you up, which are themselves mostly empty. Electrons orbiting nuclei across distances that, at that scale, mirror the distances between planets and stars. You are mostly nothing, as everything is mostly nothing. And yet here you are. And yet here is the universe, knowing itself through you, for this one small stretch of time. That is enough. That has always been enough. It does not need to be more. The emptiness around us is not a failure of the universe to be full. It is the condition under which anything can exist at all. It is the distance that allows planets to orbit without crashing. It is the silence against which sound becomes audible. It is the darkness against which stars become visible. It is the room in which everything we love, everything we have ever been, everything we will ever be, is allowed to happen. It is the reason we can hear our own thoughts. If the universe were crowded, if every space were filled, there would be no room for the small, quiet signals by which we know ourselves. Consciousness may require emptiness as much as it requires matter. The mind needs a background of silence to hear itself against. The body needs a background of rest to feel itself within. The world needs a backdrop of space to stand out as anything at all. We do not often think of emptiness as a gift. We usually think of it as a lack.
But it may be the most generous thing the universe has given us. It may be the thing that makes us possible. Every night, when you close your eyes, a small version of this truth plays out inside you. The busy signals of the day quiet down. The room grows dim. The mind lets go of its daily grip. And into the space that opens up, something else arrives. Sleep. Dreams. The body's slow repair of itself. The unconscious weaving of memory and meaning. All of this requires a letting go, a kind of inner emptiness, a willingness to stop holding on so tightly. The cosmos models this for us at its own vast scale, and we, in our small way, repeat it every night. So when the thought returns, someday when you are going about your ordinary life, that the universe is terrifyingly empty, consider that the emptiness has held you all along, has given you everything you have, has provided the quiet canvas upon which your existence is painted. The emptiness is not against you. It was here first, and it will be here after, and for the duration of your small, precious life, it is the context in which you get to be. Sleep well wherever you are. The stars are doing their slow turning overhead. The galaxies are drifting. The ancient light is passing through, as it always does. You are part of it. You have always been part of it. Nothing needs to be done tonight except to rest, and to let the great quiet hold you, as it has held everything, for as long as there has been anything to hold. If these journeys have given you some measure of peace, you are welcome back any time. For now, let the emptiness become a kind of blanket. It is vast. It is old. It is yours, in the only way anything in the universe is ever yours, which is that you are here to experience it for this little while. The stars above will continue their slow turning, whether or not you remain awake to watch. The galaxies will continue their drift. The ancient light will continue its passage.
And you, small and warm and precious, will continue to be part of it all. For the duration of your life, which is brief by cosmic standards and yet, from the inside, the only life you will ever know. Let that life rest now. Let it soften. Let the vast quiet of the universe hold you as it has always held you, from the moment of your birth to the moment just beginning now, this moment, where the words are nearly gone, where the breath is slow, where the mind is ready, at last, to let go. Good night.